Hello again, everybody. This is video number 3 for an introduction to R and RStudio. There's a lot that could be said here. We're just going to do some quick highlights just to get you started with RStudio. So in this video, we're going to be looking at some basic commands in R, things like mean, standard deviation, and also some of the formatting of the programming language itself. It's a little bit different than some other programming languages. And we're also just going to be playing with an R script, just so you can get used to an R script so that you know kind of how your code is set up. Now notice that I'm still working in a project. I'm working in this Intro to RStudio project. All of my files for that project are down here, and I have some example code ready to go. So good programming practices. These first 2 lines of code, right, are just good programming practice. This one clears the working memory, so it clears off any variables that you have lurking in the background, right? Basically, when you run this line of code, the environment tab on the top right is going to be blank. All right, the next one is to clear the graphics. Now, notice that I'm actually writing comments here within my code. Comments are started with a hashtag in R. In other programming languages, it's a % or a backslash or something else, so keep that in mind. And to run these lines of code, you've seen this in my other videos, Control-Enter. If you're on a Mac, you can do Command-Enter. It's the same thing. So I can run those 2 lines of code, and remember, of course, that RStudio will parrot those back to you right down here into the console. Now the library, I talked about libraries before that pulls in extra code. We don't need to worry about this library right now. Let's just pull in some data, same data that we played with before. This is the Tour de France data. And notice that the console gave us a couple of specifications and warnings. A lot of times you can ignore the warnings, but sometimes you do so at your own peril. So I do encourage you to at least skim the warnings and see what it says. Now, some basic R code. I've got a data set and I want to do some things to it. So let's look in this data set. Say, for example, I come all the way down here in the data set and I'm looking at the rate. So this is actually in miles per hour, how fast the winners of the Tour de France were actually riding. And I wanted to do some computation on that. So for example, I wanted to do, let's say, the mean. I want to do the mean of, now I need to pull the rate column from the Tour de France data. So I'm going to do Tour de, oh, I'm already tired of typing this, tab, and it finishes it for me. So hold on, let me do that again. Back up. I already have something in memory called Tour de France data. That's what this guy is called right here. So if I start typing that and it's in memory and I press tab, it finishes it. And then if I press $, it tells me all of the columns that are in the Tour de France data. And I can start typing. I wanted rate, tab. So tab completion allows you to, it basically saves you tons of typing. You can start typing, and if the thing's in memory, tab completion will just finish it for you. Now, my mean is the thing I wanted to calculate. So my cursor's on that line, Command-Enter or Control-Enter, and it runs it, and it spits that out to the command line here. Notice also, it didn't save anything in working memory. Well, that's kind of bad form. I'd actually like to save it as something, so I'm going to call it rate average. And in R, you use an arrow to say the rate average receives or gets the mean. Now if I run that line of code, notice that in my workspace or my environment, it actually tells me that it's stored in working memory, and it spit out just the line of code but not the answer. So one more little trick here. If I wrap that whole line of code in parentheses, it'll run the code, save it to memory, and spit out the answer for me. So for those of you that are MATLAB users, MATLAB has this semicolon that you put at the end of your code. So if you don't want to see it, you're never going to see your R code unless you explicitly tell it that that's what you want to do. Okay, let's do another one. Let's do my rate standard deviation. Now I know a keyboard shortcut to get that arrow. On the Mac, it's Option-. I don't know what it is on Windows, but remember, you can do Tools, Keyboard Shortcuts, and go find it. So again, I typed in the name of the thing I wanted, Option-, I get my arrow key, I'm going to do standard deviation of Tour de France $rate, right? And I can run it, and it populates over here into the environment. Well, let's say I wanted a histogram, so I could do hist of Tour de France $rate, and I can run that, and down here pops out my histogram. So a couple of little minor things that you're going to run into in R, the equal sign versus the arrow. In a lot of coding languages, you're going to do an equal sign as an assignment. I highly encourage you not to do that. What R is doing is it's actually making a copy of the variable, or a copy of the thing, instead of actually doing an assignment. I encourage you to use the assignment, the arrow. And weirdly enough, you can also do something like a right arrow, and it'll actually still work. That's bad programming practice, so I hesitate to show you that, but you can actually use the assignment pointing left or pointing right, whichever way. Other things that you're going to run into in R, sometimes you're going to want to see your plot a little bit bigger so you can expand out, or this is RStudio, you can expand things out. You're also going to want to make your code readable, so I highly encourage you to use comments and actually tell the reader of the code what it is that you're going to do. The reader of the code is usually future you, so you should probably tell future you what it is that you did so your code's actually readable. I think that's going to be it for this video. More to come.